Hello everyone, I welcome you all to today's session wherein we will be continuing our discussion of the numbers topic that we have been doing in the previous 3 videos. So, in the fourth part of numbers, what we will be doing is we will be covering the remaining part of factors along with the concept of coprimes. So, that is the agenda for today. So, today's session will be covering quite a few topics, but to get a more detailed understanding of it, what I would suggest is, if you are planning to go for your MBA, please go and visit the time center in your city, around you, near you, right, and check what courses are they offering, what will be relevant for you, and try to join well within time. Second point is to have access to or to watch more such videos, right, please ensure that you subscribe to our channel, because we have uploaded quite a few videos on the quant area on two fronts basically. One are the concept videos just like this one, and second is questions video that will be that are also uploaded on our channel. You can have a look at them. I am sure they will be of some help for you. Let us move on to the today's topic, which is factors third part. And we will also discuss the coprime part. Just to recap, in the previous classes, we have covered product of factors, sum of factors. That is the extent to which we have covered. Now, today we shall be looking at the concept of coprimes. Let us start with this. Now, what do you mean by coprime, right? What do you mean by coprime pair? What do you mean by coprime group? Let us try to understand that. A group of numbers is said to be coprime. A group of numbers is said to be coprime if there exists no common factor in the given numbers. Example, if you take numbers like 12 and 25 for example, so factors of 12 are 1, 2, 3, 4, 6 and 12. Factors of 25 are 1, 5 and 25, and as you can see, besides 1 there is no common factor, hence we can say that 12 and 25 will be coprime pair. So, a pair of numbers or a group of numbers which have no common factor besides 1 will be called as a coprime pair or group. So, once you understand what is coprime, please understand the following aspects also. What all group of numbers can we be sure that they will be coprimes? So, they will be, if you take any two consecutive natural numbers n and n plus 1, such a pair will always be coprime. If you take any two consecutive odd numbers, they will always be coprime. If you take any two prime numbers, they will always be coprime. So, these are some standard group of numbers, pair of numbers which shall always be coprime. Now, based on this coprime concept, we have some additional points pertaining to factors. Let us study them. So, the next point about factors is number of numbers less than n and coprime with n. Now, this is simply represented as phi of n, this is read as phi. So, next point is, what do we mean by phi of n, how do we calculate it? So, to understand this using a small example, say if I take the value of n as 20, it is 2 square into 5 power 1. Now, below 20, how many numbers are there? So, number of numbers less than 20 and also coprime with 20. Now, can we say if a number has to be coprime with 20, that number should not be a multiple of 2, that should not be a multiple of 5 also. So, that means From 1 to 20 we have 20 numbers, right? Overall 20 numbers. Now from this I need to remove those numbers which are multiples of 2. Now how many numbers are multiples of 2 in the first 20 numbers? So 2, 4, 6, 8, so on till 20, there are 10 numbers which are multiples of 2. So let's remove them. How many numbers are multiples of 5? So that's 4, 5, 10, 15 and 20, 4. But please note, when you're removing multiples of 2 and multiples of 5, there are certain numbers which are subtracted twice, for example 10. So 10 will be subtracted here also because it's a multiple of 2, 10 will be subtracted here also because it's a multiple of 5. Same way, 20 will be subtracted here also and here also, thus we need to add back few numbers. How many numbers are to be added back? Please note there are only 2 numbers that are to be added back, yes, 10 and 20. So we'll add this. So thus overall below 20, how many numbers are co-prime with 20? So can I say this should be my answer, which could be written as 10 is nothing but 20 by 2. This is 20 by 5. Take out 20 common, 1 minus 1 by 2. Take out minus 1 by 5 common, 1 minus 1 by 2. Yes. Now take 1 minus 1 by 2 common. You will be left with 1 minus 1 by 5. So this should be our answer finally. And when you simplify this, so 20 into 1 minus 1 by 2 is half into 4 by 5. So when you solve this, it's going to be 8. So there will be 8 numbers less than 20 and also co-prime with 20. Let's verify that. Is it actually correct? So let's write down the list. So how many numbers are less than 20 and co-prime with 20? So there will be 1, there will be a 3, no 5, there will be a 7, there will be a 9, 11. So ignore all the even numbers, also multiples of 5, 13, 17 and 19. These are the numbers. Now what is the count here? Please note there are 8 numbers. So thus we may write 5 of 20. So number of numbers less than 20 and also co-prime to 20 is 8. But is there a direct formula for finding out phi of n? The answer is yes. So phi of n is given as, now n is the same that we have written in the previous topics also. So n is of the form a power p so phi of n will be equal to n into 1 minus 1 by a into 1 minus 1 by b, where a, b, c, d are all prime numbers, prime factors. So this is going to be a phi of n. And as we can see here, this phi of n seem to work. The formula seem to work here, absolutely. So this is the formula that we have for phi of n. Now there are some properties that we need to remember with respect to phi of n. One of the points about phi of n is phi of n is always even except for n equal to 2. That's a special case. Next point is sum of phi of n's, sum of the numbers in the list equidistant from either ends is equal to the number itself. Let me just show it to you once. So for example, if you look at this list here, sum of the first number and the last number is the number itself, 20. Sum of the second number and the second last number, 3 and 17, again 20. Third number and the third last is again 20. Fourth number and the fourth last is again 20. So that will always be true. Right? Sum of numbers equidistant from either ends is always equal to n only. So that's one concept that we have under factors, which is nothing but phi of n's. Now next point, sum of phi of n's. So what will be sum of all these numbers, for example? So phi of 20 is, alright, whatever is the list, what is sum of all those? So can I say phi of 20 is 8? So if the number of numbers is 8, can I say there will be 4 pairs 8 by 2? and each of the pair when added will be equal to the number itself. Yes, for example, this pair here is equal to the number itself, this pair here is equal to number itself, this here again is equal to number itself, and this here is equal to number itself. So, if there are 8 numbers in the list, can I say there will be 4 pairs and each pair will be equal to the number itself. So, sum of phi of n's will be equal to. So, how many numbers are there in the list? Phi of n numbers are there. So, what will be number of pairs? By 2. And each pair will be equal to n. So, phi of n by 2 pairs when added will be equal to this much. So, this is the formula that we have for calculating sum of all the phi of n's. I hope you are okay with this, clear with this. A small example from this could be, please look at this question. If n is equal to 150, find the sum of all the numbers less than n and co-prime with n. So, he is asking us this sum of phi of n's. So, firstly we need to prime factorize it. So, what is phi of n equal to? So, phi of n will be equal to the formula n into 1 minus 1 by 2 150 into 1 by 2 2 by 3 into 4 by 5. So, when you simplify this 2 into 3 into 5, 30 we will go 5 times, it is going to be 40. So, phi of 150 we know is 40. So, what will be sum? So, my answer, this formula now. So, phi of 150 by 2 into 150. So, it is going to be 40 by 2 into 150. So, when you solve this, it will be 3000. So, the answer is going to be 3000 out here. I hope we are clear with this. Now, the next point, number of ways to write n as product of two co-prime factors. So, what is the number of ways of writing the number n as product of two co-prime factors? So, what will be the number of ways, right? So, I will just share the formula, and but before that, let me try to present the logic here. So, if you take the number n to be, let us say 360. So, in how many ways can we write 360 as product of two co-prime factors? So, one of the ways will be 1 into 360, right? The other could be 3 into 120, no. 4 into 90, no. 5 into 72. There's one more, right? 6 into 60, no. 8 into 45, yes. Both are co-primes. 9 into 40, yes. Both are co-primes. 10 into 36, no. 12 into, we are going manually right now, huh? We are doing it manually. 12 into 30, there's one more way, no, but because 12 and 30 are not co-primes. 12, 13, 14, 15 into 24, no. 16, no. 18, 20, no. That's it. These are the only 4 ways. We have only 4 ways. But how do we get to this answer actually without manually counting it? So, there is a small method for that. So, I want to write this n as, by the way, 360 is made up of what? 360 is nothing but 36 into 10. Prime factorizing it, 2 square, 3 square, 2 into 5. So, 2 cube into 3 square into 5 power 1. This is what 360 is made up of. Now, I want to write this n as product of 2 factors, right? Now, the 2 factors must be co-prime also. How can we do that? Please observe. Now, can I say if you want the factors to be co-prime, one thing is certain, I cannot distribute this 2. I cannot put 2 here and 2 square here, because if I do that, the two numbers are no longer co-primes. We cannot do that. So that means I need to place this 2 cube entirely either in this place or in this place. So thus can I say there are two ways to place this 2 cube number in one of the two numbers. Similarly for 3 square there are two ways. For 5 power 1 also there are two ways. It could either come here or here. So overall what is the number? So 2 into 2 into 2, 2 cube. However, realize this. Realize the following point. If I place 2 cube here and 3 square into 5 here, this is one way of writing n as product of two co-prime factors. I could also put 2 cube here and 3 square and 5 here. But please realize these two cases are not two different cases but one and the same, because the variables are not defined. Whether I take it as 2 into 3 or 3 into 2, it doesn't really matter, because as long as he says product of two numbers should be n. Now order of the two numbers is not important. So hence can I say when you write it like this 2 cube, 2 into 2 into 2, you are taking unnecessarily two cases. These two cases should eventually become 1. So if two cases should become 1, so 2 cube cases should become by 2, which is 2 square. 2 power 3 minus 1 is 2 square, which is 4. So there are 4 ways to write the number as product of two co-prime factors. So hence the formula, so number of ways will be simply equal to 2 to the power k minus 1, where k is number of prime factors of n. So 2 to the power 3 minus 1. Now what is that 3? 3 is the number of prime factors, 2, 3 and 5. We had only 3 prime factors, so 2 to the power 3 minus 1 is going to be our answer for this. I hope we are clear with this. So these were the points I wanted to take up in today's session. So with this we have come to the end of the session today, right. I hope you found out the session to be valuable. In case of any inputs, please do comment and write down your views about the video, and also as I was saying in the previous videos too, if there is any particular topic that you want us to take up, please do mention that, right. Or if there is a particular type of problems you want to take up, please do mention that. We will try to upload a video regarding that. On that note, let me end the session here. Thank you and all the very best.